Welcome everyone. Today I will discuss the basic concept of inverse circular function. This is included in CBSE syllabus as well as West Bengal Board of Higher Secondary syllabus. And you get one problem from this topic in any competitive exam. So, inverse circular function. Today I will discuss only the basic concept. So, look, if sin theta equals to half, then from our basic knowledge, we know theta equals to 30 in first quadrant and second, and 150 degree. 30, 150 degree. Also, 30 plus 360, 390. So, sin theta equals to half. So, what is the smallest value? Theta equals to 30. Now, look, if sin theta equals to 1 by 3, you know sin theta lies between minus 1 to plus 1. So, this is possible value, but we cannot find value of theta without using trigonometric table. So, what is sin theta equals to half? So, sin theta equals to half means sin 30 equals to half. Sin theta equals to half, what does it mean? Implies theta is such an angle whose sine is equal to x. Sin theta equals to half. Theta is such an angle whose sine is equal to x. So, what is theta? Theta equals to 30. So, sin 30 equals to half. Now, in general, if sin theta equals to x, and this restriction should be noted, sin theta equals to 2, you know it is not possible. If it is possible, so theta is such an angle, means theta is such an angle whose sine is equal to x. Whose sine is equal to x. So, this is conversely written as, this is conversely written as theta equals to sin inverse x. So, if sin theta equals to x, then theta is such an angle whose sine is equal to x. We express it in this notation, theta equals to sin inverse x. So, similar definition for other trigonometric function, that is, if cos theta equals to x, then theta equals to cos inverse x. So, sin inverse x, cos inverse x, tan inverse x, cot inverse x, sec inverse x, cosec inverse x, they are known as inverse circular function. Inverse circular function. So, listen again, sin theta equals to half, you may get theta equals to 30. But if sin theta equals to 1 by 3, you cannot find theta. So in general, if sin theta equals to x, then we write theta equals to sin inverse x. So similarly for other trigonometric function, cos theta equals to x, theta equals to cos inverse x. So sin inverse, cos inverse, tan inverse, cot inverse, sec inverse, cosec inverse, they are known as inverse circular function. Now, why it is called inverse circular function? Theta equals to sin inverse x. Suppose x is measured in radian. You know, angle can be measured in degree. This is sexagesimal system. If it is measured in radian, then it is circular system. Here angle is measured in radian. What is the relation? If it is in terms of degree, we transfer in terms of radian. 180 degree equals to pi radian. So it is measured in radian. That is in circular system. That is why the name circular function. And theta, sin inverse x, this angle is measured in radian and it is obtained in inverse process. That is why it is called inverse circular function. So number one, it is measured in radian, that is in circular measurement. And number two, it is obtained by inverse process. That is why it is called inverse circular function. Now, you know a to the power minus 1 equals to 1 by a. From rule of indices, sin inverse x, this is not equals to 1 by sin x. So sin inverse x is an angle and 1 by sin x is a pure number. So you cannot write sin inverse x equals to 1 by sin x. So this to be noted. So this is introduction. What is inverse circular function and how it is obtained. Then in CBSE syllabus, first topic is domain. So domain and range of inverse circular function. Inverse circular function. What is domain and range of inverse circular function? So you should remember it. Function, domain and range. You know, domain is value of x. So domain is value of x for which function is defined, and range is value of function. So sin inverse x. So what is domain? X lies between minus 1 to plus 1. So cos inverse x. So x lies between minus 1 to plus 1. Tan inverse x. You know, tan can take. Tan inverse x equals to a. So tan a equals to x. So x can take any real value. So minus infinity to plus infinity. So you should remember, infinity, this is idea of very, very large number. It is not a number. So that is why we are taking always open bracket. Infinity is not included. So cot inverse x, minus infinity to plus infinity. Sec inverse x. So value of sec does not lie in between minus 1 to plus 1. So that is why you can write it in this form. Minus infinity to 1 and this is 1 to infinity. and cosec inverse x. Same, minus infinity to minus 1 union 1 comma infinity. So if it is real line, it is 1, it is minus 1. Sine and cos. Here sine inverse and cos inverse. But this is sec inverse. Greater than 1. Cosec inverse. All of you know it. And less than minus 1. Sec inverse, cosec inverse. Look. Minus infinity to minus 1, then 1 to infinity. So this is for sec and cosec. So all of you know it. Now range. So range of sine inverse x or principal value. This is minus pi by 2 to plus pi by 2. So if you put 1, so sine inverse 1, this is pi by 2, minus 1, because it is increasing function. And cos, what is range? 0 to pi. Tan, minus pi by 2, 2 plus pi by 2, open bracket. Sec also same, 0 to pi, open bracket, sec inverse x. So same that of sine, but it is that of sec, that of cos. So cos inverse x, but one point is not included, that is pi by 2. At pi by 2 it is undefined. So it is minus pi by 2, 2 plus pi by 2, minus 0. So this is cosec. So you have to remember this table. So domain and range of trigonometric function, inverse circular function. So this is our first value. So find the domain of, so right, find the domain of sine inverse 2x minus 1. Number 2, cos inverse 3x minus 1. Number 3, sine inverse x square. Number 4, cos inverse x square minus 4. Number 5, 2 cos inverse 2x plus sine inverse x. Sine inverse x. Sine inverse x, 2x plus cos x plus cos x. Number 7, sec inverse 3x minus 2. Cosec inverse 5x. So domain, this is value of x for which function is defined. So you should remember this table. So we are finding domain. So if argument is linear, then it is very, very simple. Suppose 1. So fx equals to sine inverse 2x minus 1. So what is domain? Domain is x lies between minus 1 to plus 1. Therefore, fx is defined when minus 1, x is replaced by 2x minus 1. So this argument lies between minus 1 to plus 1. And domain is the value of x. So solving this inequation, you have to find x. So add 1 on both sides. So 0 less than equals to 2x less than equals to 2. Adding 1. So then dividing it by 2. 0 less than equals to x less than equals to 1. So what is df? 0 comma 1. 0 comma 1. So this is domain. df equals to 0 to 1. So cos inverse 3x minus 1. So same type lies between minus 1 to plus 1, then find value of x. This is very simple. Next, problem number 3 and 4. They are of same type. Sine inverse x square. So fx equals to, so you consider this one, cos inverse x square minus 4. Cos inverse x square minus 4. So fx is defined when argument, this one, lies between minus 1 to plus 1. Now, so if we consider right hand side, so x square minus 4 less than equals to 1. So x square minus 5 less than equals to 0. So x minus root 5 and x plus root 5 less than equals to 0. Do not write x lesser than equals to plus minus root 5. It is a quadratic inequation. You know how to find solution. So factorize this. And you know, if coefficient of x is positive and if it can be factorized, then if it is less than, then value lies inside the interval. So, you know, if x minus 1, try to recall, this is less than 0, then 1 less than x less than 2. It lies between 1 and 2. Because if you put any value in between 1 and 2, it is satisfied. Suppose 1.5, it is positive, it is negative. So total is negative. So what we are getting? Minus root 5 to plus root 5. This is lesser than equals to. So this is the value of x. Minus root 5 to plus root 5. Now, one more, this one. So minus 1 lesser than equals to x square minus 4, or you can write it in a reverse form, greater than equals to minus 1. So minus 1 less, so you are writing it in a reverse form. So x square minus 4. So x square minus 3 greater than equals to. So x minus root 3 into x plus root 3 greater than equals to 0. I have already discussed it. It is linear factor, product of two linear factor. If it is greater than, so then it lies outside the interval. This is root 3, this is minus 3. So what is the value of x? X belongs to outside. This means less than minus root 3. So minus infinity to minus root 3. Union root 3 comma. So you should know the how to solve the linear inequation of class 11. So x belongs to this. Now you are getting two cases, this one and this one. Then we have to take the common part of this. So look, so if we draw the figure, this is root 5, this is minus root 5, this is root 3 and this is minus root 3. So this one to this one. First case, minus root 5 to plus root 5. And second one, greater than root 3, less than minus. So what is the common part? Common part is this one and this one. So what is domain of f? Final conclusion, df equals to common part of this and this. What is common part? Minus root 5 to minus root 3 union root 3 to root 5. So if argument is second degree, then it is you have to solve quadratic inequation. So look it again, fx equals to sine inverse x square minus 4. So x square minus 4 lies between minus 1 to plus 1. So considering this one part, we are getting this, and considering second part, we are getting this, and taking common part, we get domain. So these are problem of competitive exam. So similarly, you can find domain of sine inverse x square. Exactly same. Now, domain of two functions. So look, fx equals to sine inverse 2x plus cos x. Fx equals to cos inverse 2x plus sine inverse x. So if it is given as sum of two functions or difference of two functions, we find domain of this and domain of this. Then take the common part. So consider first one. So fx equals to, so this is hx and this is gx. So hx equals to sine inverse 2x. So what is the domain? Very simple. Minus 1 to plus 1. So what is d of h? Domain of h, minus half to plus half. And gx equals to cos x. So you know cos x is defined for all values of x. So d of g equals to r, real number, set of real number, that is minus infinity to plus infinity. Now what is domain? Domain is common part of hx and gx. So look, this is minus half, this is plus half. So domain of h. And domain of g is minus infinity to plus infinity throughout the interval. Now what is the common part? The common part is minus half to plus half. So therefore, domain of fx, that is df, equals to d of h intersection d of g. So what is the intersection part? Common part, minus half to plus half. Minus half to plus half. So if there are two functions, we take the intersection part. Next, sec and cosec. So 7, sec inverse 3x minus 2. So this is fx. So recall the domain of sec x. So fx is defined when 3x minus 2 less than equals to minus 1 and 3x minus 2 greater than equals to 1. Argument is greater than equals to 1 and less than equals to minus 1. So 3x less than equals to 1. So x less than equals to 1 by 3 and 3x greater than equals to 3. So x greater than equals to 1. So what is domain? df equals to greater than 1, that is 1 comma infinity, greater than 1, and union less than 1 by 3 minus infinity to 1 by 3. X greater than 1 to infinity, and this is minus infinity to 1 by 3. So you should remember the table of domain of inverse circular functions. So exactly same problem number 8. Next, now we consider domain of fx equals to sin inverse root over x minus 1, sin inverse root over x square minus 1. These are also problem of WBJE. So fx equals to sin inverse this. So suppose problem number second one. So fx is defined when minus 1 lesser than equals to root over x square minus 1 and lesser than equals to 1. Because sin inverse x is defined when this one. Now second restriction, you know root over thing. So if argument of root over thing is positive, then it is real. Otherwise it is imaginary. Therefore, what is our second restriction? Second restriction is argument must be greater than equals to 0. So x square minus 1 greater than equals to 0. X square minus 1 greater than equals to 0. Argument must be greater than equals to 0. So no negative part. So considering these two, we can write 0 lesser than equals to x square minus 1 lesser than equals to 1. So negative part is excluded. Now we consider x square minus 1 lesser than. Since it is positive 1, so x square minus 1 lesser than equals to 1. So x square minus 2 lesser than equals to 0. So x minus root 2, x plus root 2 lesser than equals to 0. So x belongs to minus root 2 plus root 2. This one. Now you consider this part. So x square minus 1 greater than equals to 0. So this implies x square minus 1 greater than equals to 0. So x minus 1, x plus 1 greater than equals to 0. So greater than, that is value like outside. So x belongs to minus infinity to minus 1 union 1 to infinity. Now we take the common region. So if you draw the figure, look here, this is root 2, this is minus root 2. For 1 is less than root 2, this is 1. And this is minus 1. So first one is in between minus root 2 to plus root 2. And second one is this. So what is the common region? What is the common region? So common region is the domain. So df equals to minus root 2 comma minus 1 union 1 comma. So this is domain. So listen, lies between minus 1 to plus 1. but root over thing must be positive. So only positive part to be taken. So minus 1 to 0 is minus 1, negative part is cancelled out. So that is 0 to 1. Then solving, we are getting 2 restriction, take the common part. So this is problem of competitive exam. So today, through this video, I have discussed how to find domain of inverse circular function. This is most important chapter of any syllabus. So thank you for today.